Welcome back everyone, bine ați revenit în spațiul nostru Virtualized, care este, sper că ați găsit lucruri interesante în plimbările voastre prin Expo. Am încercat să vă găsesc în lobby pe fiecare dintre voi, dar fiind foarte mulți, firește că n-am putut să vă salut pe toți. De aceea sper să fiți pregătiți să facem un, să spun așa, upgrade de performanță în debugging și writing code. Având în vedere termenii tehnici pe care îi vom folosi în următoarea prezentare, aceasta se va desfășura în limba engleză, deoarece, hai să nu ne ascundem, aceasta este limba în care practic am învățat cu toții calculatoarelor și dacă se spune la noi că vorbim romgleză, la noi IT-știi sau mediul IT din Franța vorbesc frangleză, acum am ales ca pentru următorul speech să se vorbească în plină limbă engleză ca să înțelegeți termenii în mediul lor natural. Această performanță și optimizare de performanță este posibilă printr-o combinație optimă cu metodologia și tool-urile corecte. Dar mai mult despre acest lucru o să-l las pe domnul Gabriel Bornea, care este Chapter Lead la ING Tech România. Gabriel, te rog.
So hello everyone. I'm very happy that you are all here and that you are interested in functional programming. As a side note, this presentation is aimed at Kotlin and at Arrow, so it has some assumptions that you are already a little bit familiar with Kotlin and let's say with the differences that are between Kotlin and the Java programming language. So I will share my screen and we'll start the presentation. So hopefully everyone can see it. A little bit about me in the beginning. My name is Gabriel Bornea. I am a software engineer at ING Tech. I'm not a functional programming expert, and this presentation is based more on the experience that I've had over time with applying functional programming concepts within the applications we write in every day. So I do functional programming whenever I can, because obviously I cannot do it anytime I want. I usually program in Kotlin, Java, and Scala, mostly in this order, but I'm also learning Haskell and F# lately. And I am also the organizer of the Kotlin user group in Bucharest. Today, I will try to show you how you can write pure functional applications without having to master things like category theory or other mathematical theories. We need, however, to know that things like monads, type classes, and higher kinded types exist, but the goal in the end is to be able to write applications using them as little as possible. So fundamentally, functional programming is based on a very simple idea, which is writing software applications using only pure functions and immutable values. And just by looking at this definition, you might think that every language can write pure functional code. And in a sense, that is true, but there are some limitations that we are going to see in the next part of the presentation. But before we go any further, let's see what a pure function is. The output of a pure function always depends only on its input arguments and its internal algorithm. It has no side effects, which means that it does not read or write anything from the outside world. And if a pure function is called with the same input arguments an infinite number of times, it will always produce the same result. Unfortunately, since this is an online presentation, I cannot be as interactive as I usually am in these talks, because right now is the time when I would have asked you if this function is pure or not. But since you cannot answer, I will answer it. The fact that it returns unit, it's a clear indication of a side effect, because a function, in order to be useful, if it returns unit, it has to do something like changing a state outside of its local environment. In this case, it's printing something to the console. We can make it a little bit better right now by making it return a function instead of returning immediately a value. And Kotlin uses this special notation type to specify functions where between the parentheses you have the argument types, and after the arrow you have the returning type. Why did we do this? Because right now we are in control of when the side effect is executed. So right now, only when I'm invoking the function, the side effect will be produced. But why would we use pure functions? Well, because the output depends exclusively on the input. Pure functions are easy to combine. And I'm going to show you a very simple example where we have three functions that we want to execute in this specific order: add 1, multiply by 3, and divide by 2. We want to combine them. So what we could do using the standard library is write it like this, where add 1 will be executed first, multiply by 3 will be executed second, and divide by 2 will be executed third. But there are a couple of issues here. The first one is that it's quite difficult to read, and you also have to know that the innermost one gets executed first. And also the function immediately returns a value, in this case an int. So let's try to make it a little bit better. And for that we can use compose. But just like in the previous example, the order is still the other way around. So we have add 1, multiply by 3, and divide by 2. But the good thing is that right now, instead of immediately returning a value, we return a function that we can control when we want to execute it. Compose is not part of the Kotlin standard library, but can be easily added as an infix extension function to a function that takes one argument and returns a value. We can do it even better than this by using and then, and now we have the reading order that we want the functions to be executed. So now it is clear that add 1 is executed first, and then multiply by 3, getting the result of the first function, and divide by 2, the last one. As previously, it returns a function, which is very good. And yeah, as you might have guessed, and then is not part of the standard library, but just like compose, we can add it very easily, just like before. Other reasons to use pure functions are that if there is no data dependency between pure functions, the order in which they are executed can be reversed or parallelized. Pure functions are deterministic, meaning that how many times they're executed with the same input, they will always produce the same output. Pure functions are referentially transparent. This means that replacing a function with the resulting value will not change the behavior of our application. Because a pure function always returns the same result given the same input, the compiler or our application can choose to cache the result, and this is a process that is known as memoization. And the pure function can be tested much easier because it only relies on its internal algorithms to produce the output. And this makes it a lot less prone to creating a lot of plumbing around it in order to work. So we've talked about pure functions. Why would we use immutable values? Well, because they're inherently thread safe, so there is no synchronization issue, and this makes the parallelism a lot easier. And in our application these days, this is what we want, a lot of parallelism within the application. Let's look a little bit closer at side effects. So a function or an expression is considered to have a side effects if it modifies some state outside of its local environment. Meaning that it has an observable effect besides returning a value. So let's see a little example where we have a function f, and this function takes an input argument, x, and it produces some f of x. And in this case, a side effect would be that somewhere within the execution of this function, we would, for example, insert a new row within the database, which means that we have changed the state outside of our local environment. And other examples could be writing to a file, reading from a database, calling other services, and even user input is considered to be a side effect. But from the business perspective, side effects are desired effects. So in order to change a client's balance, we have to update something in the database or request that from an external service. In order to debug our application, we have to write log files or we have to put logs someplace else. So if functional programming doesn't allow side effects, it kind of seems useless, right? We can build beautiful systems that cannot do anything. So we need some sort of a connection between our pure, beautiful world and the messy real world to make our program useful. And these are called effects. And effects are related to monads. And when people get into functional programming, they get scared away by things like forget everything you know about programming, and that is completely nonsense. Because as I've said earlier, functional programming is only about pure functions and immutable values. A monad basically is just a design pattern that abstracts over the ability to declare sequential computations that are dependent in the order or the result of the previous computation. So you can see it just as a program, a design pattern that allows structuring programs, basically a program in itself. And it allows transformation via map and composition via flat map with other programs, other monads in our case. So by seeing this, is Kotlin a functional programming language? Well, the short answer would be no, but it offers great support for functional style. So we have higher order functions where functions are treated like values. We have algebraic data types through sealed and data classes. We have immutability by using the val keyword, and almost everything is an expression, which is great. But there are a few things that we miss that will allow us to write pure functional code. And one of them are the type classes. And type classes are basically an abstraction that is associated with one type. So you can view them as extension interfaces. And their basic goal is to add new functionality to types or to abstract over some behavior. So we could do something with Kotlin right now to emulate type classes. So if we take this example where you have an interface that it's over some generic type that all it does is check for equality between two of the same types. And assuming we have a user and we want to check equality for that user, basically it would mean that the ID is equal to the other user ID. So what we could do right now is create an object where we override the function that checks for equality with the behavior that we want. And so far so good. But the problem is that in order to run it, we either need a run block, so it's not automatically imported or automatically available, or we could do it with the with function that takes the user equality check, and also the inside of it we have access to the two functions. So Eric Meyer calls this the poor man type classes in Kotlin. But the guys from 47 Degrees, they have opened a language proposal to the Kotlin language to bring this within the language itself. We'll see a little bit more about that later. Another thing that we miss are higher kinded types. And the higher kinded types are types that contain a type constructor, and that type constructor further contains another type constructor, where a type constructor is any class or an interface that has at least one generic parameter. Yeah, I know it's a kind of fuzzy definition if you hear it for the first time, but basically it's something that would look like this, f of a, where f is generic and also a is generic. But the problem with this is that in Kotlin, the compiler doesn't allow it. And even in Java, this is not allowed. It is possible, for example, in Scala, which is another JVM language that supports higher kinded types. But based on a paper called Lightweight Higher Kinded Polymorphism by Jeremy Yallop and Leo White, we could emulate this within languages that don't support higher kinded types. And in Kotlin would look something like this, where we have an interface kind that contains the F, which is the container, and also A, which is the contain type. So we have both generic types within that kind. So why is this useful? This is useful when we try to write polymorphic applications, and we'll see a little bit about that later. But thankfully, we have a library called Arrow, which is a library for typed functional programming in Kotlin, which is highly modular and built of a lot of modules. Arrow core being the basic building block of the entire ecosystem, which includes a lot of popular data types like option or either. The Arrow FX, which is basically the companion to the Kotlin native suspend system. Arrow Optics, which takes away all the boilerplate when you work with highly nested data structures. Arrow Meta, which is a library that basically works with the Kotlin compiler in all of its phases, and again helps a lot with removing a lot of boilerplate code. The Arrow Incubator is the place where you find the Arrow query language or the MTL. You can check on their website if you're interested to know more about that. But yeah, today we are going to look at ArrowFX. And as I've said, ArrowFX allows you to write polymorphic applications and acts as an extension to the Kotlin native suspend system. Before we go any further, I want to stop for a little bit and talk about the IO monad. IO monad is used to represent operations that can be executed lazily and are capable of failing, generally with exceptions. What this means is that the code wrapped inside it will not throw exceptions until it is run, and those exceptions are captured anyway within the IO, and you can check them later. If you're coming from an object-oriented programming background, the simplest way to use the return value of an IO is to consider it as an asynchronous operation that you can register a callback for. And going back again to ArrowFX, at the beginning of the presentation, we saw the function grid that produces side effects, and this cannot be used in the context of ArrowFX. We saw that we can make it a little bit better by returning a function, but it's still not very helpful right now. The first thing we can do is to wrap the entire function within an IO, and thus we turn it into a lazily pure function. Or we can use the suspend keyword, so we take away all the definition of IO and away, and we just use the Kotlin language as much as we can. Okay, right now we're going to go through a very simple example where we print a welcome message to a user. Then we get the input from the user. And at the last step, we actually greet the user using the message that he provided. So the first step would be to add the suspend keyword to all the functions. So right now we have suspend fun print, suspend fun get, and so on. And okay, we made it suspension functions, but now we need a way to compose them. And side effects can be composed using fx blocks, and it would look something like this. If you're familiar with Scala or with Haskell, the fx is pretty similar to the for comprehension from Scala or the do notation from Kotlin, from Haskell. If we run the code right now, we will get a compilation error, and that happens because Arrow enforces effects to be applied explicitly. So what we have to do is to explicitly add the effect function in front of the side effect that we call. And what it does, it wraps the side effect and turns it into a pure value. If we compile the code, yeah, we get another compilation error because at this time, effect doesn't return the value that we expect. So for example, the greet user function takes a nullable string, but it gets something called kind of for IO and nullable string. And this is a higher kind type, the one that I showed you earlier. So what we need is some sort of a way to extract the value in a non-blocking manner. And for that, we have three options. But I think from the next version of Arrow, we'll only have two. We can use destructuring, which is based on the Kotlin component 1, component 10 functionality. And this way, we actually get the value in a non-blocking way out of the container. But the problem with this is that it is deprecated due to some problems that we used to have. So I wouldn't recommend on using it. But thankfully, we have the not operator, which we can use, and it has the same desired effect. And we could also use the bind function directly directly on the effect function. Okay, so now we've written the program, but now we have to run it. So we can execute it in a blocking manner or in a non-blocking manner. But yeah, since they both produce side effects, they have to be run at the outer edge of our system. So in this case, for our main function, we have to wrap it within an unsafe way of executing our code. And if we have RESTful APIs, this will be the place of the controllers. If we have Android applications, we have Android or activity, or for other, we have main. So right now, if we run the application, we will get our desired effect. I want to show you another example that is more coming from a real world and what we did within our projects to use ArrowFX. And I'm going to take an application that manages accounts, and those accounts are managed within a database, and another application that manages transactions, and those transactions are placed in another service. So what we need here to access the data, we need a repository for the account to be able to find it by number and return an account, a nullable account. And we also need some client that is able to get for us all the transactions that are associated with an account. So it sounds pretty simple, right? It's something that we basically do every day within our applications. But let's see how we could do it in a functional way. And I'm showing you this example because there are different things that are important here. So the first one is that we've achieved here compile time dependency injection, and we've also achieved purity and type safety. So for example, I cannot pass as an argument to the function anything else than an account number, because this is a type. It's basically a type, and I've achieved type safety. Another thing that you might find strange here is this R, which in this case, R is an environment, and it's an environment that is capable of knowing how the account repository behaves and how the transaction client behaves. So what this means is that for any environment that knows what an account repository is and what a transaction client is, I am able to provide a function called getTransactions for account number that will be able to perform the business logic that I want. So in this case, I'm going to the account repository. So it's this one here to get the account by the number. If I don't find it, I raise an error, but I don't throw an exception. I raise an error that I will check later whenever I evaluate what this function does. And with that account, I can go to get the transactions associated to it, and then I return it. So this is basically what we did in our projects to be able to write pure functional applications with, I would say, much success. So thank you very much. If you have any questions, I will stop the screen sharing.
If you have questions for Gabriel, please use the Q&A section. I will see it immediately. Meanwhile, while they are maybe typing their questions, Gabriel, one question from me. If I understood well your presentation, what would mean for a manager in terms of return on investment that he will, let's say, ask the developers to use the system you presented? Basically, for me as a manager, if I have a development team, migrating to this system would mean an expense. What is it in it for me as return on investment?
Yeah, that's a very good question, and I will give you an answer based on one of our applications that is in production since September. Since September until now, we've had 0 bugs and 0 production incidents because we've applied techniques like type safety, like purity, and like not throwing exceptions everywhere and losing them everywhere. We've also achieved with our application an incredible amount of performance due to the fact that we used under the hood fibers instead of threads. And this way we were able to concurrently handle a lot more requests than you would normally do with a normal application written, I don't know, with a Spring Boot in a classic way. So I would say that the return is high, but obviously you need to put in some time to learn. So it's not something that is going to happen overnight.
Of course, but the return you are saying is extremely high, like no issues in production is the target of every manager possible. So yeah, there's a very, very high return on investment in this case. What would be the learning curve for this platform?
I would say that the learning curve is not that, yeah, it's a bit steep. So I would say that for a senior engineer that has only worked in the Java world and only with imperative programming and OOP, I would say that a couple of months would be needed to be ramped up. I think it's easier with novice because novice engineers don't know anything, so it's much easier to shape them.
Yes, true, very true. I confirm that. I confirm that from training people who are brand new in an area, it's very easy for the trainer to pass them the right information.